In this video, let us look at how to find the tangents to the circle from an external point. So we have already seen how to find the tangent to the circle at a point on the circle. Now if the point lies outside the circle, you can very clearly see that you can draw two tangents, right? From any external point on the circle, you can draw two tangents. That is, you can draw a pair of tangents. So how to find the equations of these tangents? So the equations of these tangents can be found in two stages. So there are two steps involved to find the tangent. The first step is, so let y is equal to mx plus minus r root 1 plus m square be a general tangent to this circle. If you have a circle x square plus y square is equal to r square, any tangent to the circle will be of this form. Now I don't want any tangent to the circle. I want that particular tangent which passes through this point x1 y1, right? So I want that particular tangent, that particular m for which this tangent passes through x1 y1. So that means y1 is equal to mx1 plus minus r root 1 plus m square. This implies plus minus r root 1 plus m square is equal to y1 minus mx1. And if you square this on both sides, you get r square times 1 plus m square is equal to y1 square plus m square x1 square minus 2m x1 y1. Now if you simplify this, you can see that you're getting a quadratic in m. Getting a quadratic in m. It is m square times r square minus x1 square, m square times r square minus x1 square, plus 2m x1 y1 plus r square minus y1 square is equal to 0. So you have a quadratic in m. So corresponding to r will be given in the question, x1 y1 will be given in the question. So if you substitute those values, so these will turn out to be some particular numbers. So you're getting quadratic in m. So solve to get two values m1 and m2. That means corresponding to a particular point, you have two possible slopes such that this tangent passes through this point. So you need to solve this, get m1, m2. That's the first stage. And once you get m1, m2, you have the point. m1 will be the first slope, m2 will be the second slope. So you have a point and a slope. You get the first equation. You have a point and the slope, you get the second tangent. So y minus y1 is equal to m1 times x minus x1. Y minus y1 is equal to m2 times x minus x1. So these are the two tangents that you get from this point. So I hope you understand how we have done this. Here you have a special case which is very important. Sometimes it may lead to confusion. Sometimes when you do the process, you will find that this m square coefficient turns out to be 0. That is, sometimes it will turn out that x1 square is equal to r square. That is, x1 is equal to plus r minus r. In this particular case, this quadratic term becomes cancelled and you get only one value of m. You get m is equal to a single value. So in this case, you get only one value of m. That does not mean that you have only one tangent, because from any external point you can draw two tangents. So if m square term is getting cancelled, that means the other value of m is infinity. It means the tangent is become vertical. One of the tangent is become vertical. So for example, if you have a circle like this, x square plus y square is equal to r square. So if you take any point on this vertical line, you take any point on this line, this is the line corresponding to x is equal to r. So if you take any point on this, you get one tangent like this and the other tangent is vertical. A vertical tangent means m is equal to infinity. So in that case, this term will get cancelled out, and you need to understand that the slope of the other tangent is infinity, or that the tangent is parallel to y-axis. One tangent is parallel to y-axis. So the tangent is of the form x is equal to constant, x is equal to r. This is fine. So let us try to practice how to use this in a standard problem.